Hello everyone and welcome to the Peach and Cooper Show. Today we will be hosting the great 2014 black hole debate between our two debaters, Stephen Hawking and Leonard Susskind. The debate is just getting steamed up.
That's right, Peach, yes. Hello everyone, you're in for a treat today. I'm very excited, so let's bring out our guests.
Hello, very glad to be here.
Hello, very glad to be here.
So glad you two could make it. Before we get into the black hole theory, we would like to ask you both a few personal questions, if that's okay.
Of course.
Sure thing.
Alright, these will be for the both of you, but Hawking can answer first. Peach?
Thanks, Cooper. Mr. Hawking, are you ready?
Ready as I'll ever be.
Great. So when and where were you born?
I was born January 8th, 1942 in Oxford, England, and at 8, I moved to St. Albans.
Care to share about your past education?
First I attended Oxford, then moved on to Cambridge University.
Were you always interested in physics?
No, my favorite subject was always math, but I ended up with physics.
Interesting. Well, tell us about your life growing up.
When I was 21, I developed and was diagnosed with amyotrophic lateral sclerosis, stifling all control in my muscles.
How has your condition stunted your development in the scientific world?
My condition does not stop me from experiencing scientific concepts, directly or indirectly. I have been in space and experienced zero gravity firsthand.
That's amazing. You've developed your black hole theories quite a lot as well.
Yes. Just this year I made an updated statement about my theory involving the loss of information from black holes. It seems to be quite popular within the science community.
And we'll hear about this in just a few moments. Let's go to Cooper with Leonard Susskind.
Alright, Susskind, care to tell a little about when and where you grew up?
Well, I was born into a poor Jewish family. Started the family plumbing business when I was 16, but I didn't want to spend the rest of my life in the plumbing business. I was much more interested in science. My parents were hesitant about this choice, but they eventually gave in, and I first went to the City College of New York as an engineering student. I graduated with a BS in physics in 1962. Let me think. Then later I went to Cornell University. That's where it was, where I earned my PhD in 1965.
Wow, impressive. Did you make any careers out of that?
Well, first I was an assistant professor of physics, then an associate professor at Yeshiva University, then at University of Tel Aviv, and I was tired of being an assistant, so ever since 1979 I have been head professor of physics at Stanford University.
Do you enjoy your job?
I love it. I love it. Head professor. 1979.
You don't hear many people say that. How about your view on this whole black hole theory?
Well, I obviously disagree with Mr. Hawking. Otherwise, we would not be here right now. I think that his conclusions violated one of the most basic scientific laws of the universe, the conservation of information.
I see. Well, I can tell you two are itching to get into this, so let's begin. Let's hear some opening statements.
My studies have shown that black holes take in information, and when black holes evaporate, the information is not scrambled, not rearranged, but obliterated irreversibly.
The basic laws of physics state that information cannot be destroyed. The theory presented by Hawking breaks this rule, and therefore it cannot be correct.
The vacuum within the black hole fluctuates so that at the event horizon of the black hole, particle-antiparticle pairs are formed, meaning that there are both positive and negative charged particles. While the negatively charged particle is absorbed, the positive particle escapes, decreasing the overall charge and size of the black hole itself. The black hole gets smaller until it evaporates, and the information inside the black hole is ultimately destroyed. This can happen so quickly that we may not even notice a black hole's existence before it disappears.
Even if black holes do evaporate, there are other theories that could explain what happens to the information in ways that are much more acceptable to the laws of physics.
Explain further.
Well, glad you asked that question. For starters, if black holes do evaporate, they would most likely leave remnants to show us that they were there. I don't know. When it finally evaporates, the quick movement, it says so right here, would produce enormous amounts of energy, and those particles would be small information box. A minuscule particle that contains all the information absorbed by the black hole prior to evaporation. That's got to be it.
Is that so?
The theory that stands out the most to me is the bathtub theory, which relates to the information leaking into space from black holes like drops of ink dropping in a bathtub. This theory says that the information is absorbed into the black hole piece by piece until it is indistinguishable and creates a muddle of information within the black hole. Like the ink dropping into the bathtub, it becomes muddy and uniformly a black pool of water. But as the black hole begins evaporating, the information begins leaking into space, escaping the disappearing black hole. The information is no longer present, but it is still in its existence. The molecules have been spread out over space and scattered.
I see. But if so, what happens to the particles in space? Do you suppose they are just floating around?
Yes, I believe so. It's hard for us to see what could really be happening to these particles, or even to pinpoint any of them. Your thoughts?
I suppose that's plausible. You win. I give up. I'm throwing a party. You're not invited.
Well, there we have it, folks. The physicist Stephen Hawking, who introduced to the world a revolutionary black hole theory that not only enlightened many, but set sparks ablaze and started endless debates within the scientific community.
And the physicist Leonard Susskind, who stood up to Hawking's theories and found his own voice in the scientific community, using his disagreement with Hawking's theory as a springboard for greater exploration into the depth of black hole studies.
My mother, her cooking.